Okay. So last week we did multiple linear regression. In this analysis, there can be several independent variables and one dependent variable. One dependent, several independent, right? Example, age, BMI, right? And let's say triglyceride. How are they all quantitative? Are they all quantitative? Yes. Right. How they make a difference in SBP? So here everything is quantitative, right?
Yes.
So this is multiple linear regression. Why is it called multiple?
Multiple variables.
Because we have more than one predictor. It's just one predictor, what do you call the analysis? Just one only? It's called
Simple linear.
Simple linear.
Yeah, simple linear.
Right. When more than one is called multiple linear. Now the question is, what if the independent variables are not all quantitative? Suppose it's a combination of quanti and quali, right? For that, we have this solution, general linear models. So general linear models, the independent variables can be combination of quanti and quali. The dependent variable must be quanti. Example, this can be, just now pointed out, age, this can be gender, this can be occupation. So now we have combination of quanti and quali. So the method is general linear models. So look at this analysis. What is this analysis called? What is this analysis? Look at the example we did last week, a couple of weeks ago. What is this analysis called? How many variables here?
Two variables.
Two variables. This one is quali or quanti? Job category. Quali. SVP?
Quanti.
Quanti.
So, logistic regression, right?
No, this SVP is quantitative variable. The job category is nurse, attendant, or doctor. That's how we did last week, right? Or some time ago. You want an SBP. Does it differ between categories, right? What is this test called?
Anova.
Huh?
Way Anova.
Way Anova. Right? So this actually Way Anova. Why is it called one way? Why is it called one way?
More than one population.
No. Why is it called one way? Why is it called one?
Because there's 2-way, 3-way, and so on.
Yeah, but why this is called one way?
Now one variable.
A single variable. It's only one variable. So it's called one way ANOVA. Just one. So even this one way ANOVA is a subset of general linear model. All right, actually this under the umbrella of general linear models. Right, even one way ANOVA. Today, we're going to start from one way ANOVA and then continue with multiple variables. As we go, we're going to give some names for the type of analysis we're doing. If there's one way ANOVA, there must be, if there's one way, there must be also
Two-way.
Two-way ANOVA. So how two-way ANOVA will work? There'll be one more variable, right? Is that right?
Yes.
Why is it called two-way? Why is it called two-way? There are two predictor variables, right? Plus,
Yes.
just now
Yes,
one way, just one predictor. Now become two-way because of two predictors. If I put one more variable, marital status,
It will become three-way ANOVA.
huh?
Will it become three-way ANOVA?
Three-way ANOVA. So anything more than two,
Multiple.
multifactorial ANOVA. So this we call multifactorial. Multi means what? Many, right?
More than one, actually.
Now, multi means many, right? Class, multi means what?
Many.
Many. So we start with one-way ANOVA, one variable, two-way ANOVA, two variables. Anything more than two, we call it multifactorial ANOVA. So each one's a factor. 1, 2, 3 factors. Just one factor only is called one-way ANOVA. Just one factor only. If there are two factors, add one more factor. Now you call it two-way ANOVA. Anything more than 2, 3 and above, we call it multifactorial ANOVA. We're going to do all this today. And most of the time, for your research, for your thesis, whatever, if it's multivariate, most of you may require this or higher, right? So no thesis will just depend on whatever done so far. Will be multivariate, right? So multivariate, it can be quantitative outcome and all these quantitative, then multiple regression. But often these variables are mixed. Then it can't do multiple linear regression. We go to general linear model. As I said just now, a simple one-way ANOVA is a subset of general linear models. Two-way ANOVA, still subset of GLM. We call it GLM, general linear models, GLM. Right? GLM, general linear models. Okay, GLM, symbol, short form. And expanded to two-way and expand to multi-way. And let's start with what you done earlier. One-way ANOVA. We're going to do hands-on. All right. What's objective? What's objective? What's objective?
If there is a difference in mean SBP between job category.
SBP and job category. So open the data file. It's my data. SBP and job category. Okay. I want to know whether the BP differ between job category. How many variables here?
2.
2.
2 variables. Are they quantitative or qualitative?
One is qualitative.
One is qualitative, one is quantitative. Can I do t-test? Can I do t-test? When do you do t-test?
When there is more than one population.
T-test, independent sample t-test. When do you do independent sample t-test?
When there is two population.
Only two groups, right? Male, female.
Yes.
Either male or female. But here, there are more than two groups, right?
Yes.
The person can be a nurse, can be an attendant, can be a doctor. So more than two groups, we do one-way ANOVA.
No.
Am I right?
Yes, Prof.
Right. Let's do this. Analyze.
Compare
By means.
one way.
Ma, right? Is it Ma who's talking?
One way ANOVA.
Okay, one-way ANOVA. What's next step? What do you want to know? SBP and job category, right?
Yes.
Where does SBP go? In the dialog box. It's called dialog box.
Dependent.
SBP dependent, job category, factor.
Factor.
Then what do you do?
Options.
Options. So this is what you're going to do for your assignment 3, okay? Right?
Descriptive.
All right.
And homogeneity.
Descriptive and homogeneity of variance. Continue. And click OK. Have you done this before?
Yes.
Variances, are they similar? What's the p-value for variance?
0.05.
0 point?
0.05.
Less than, is that?
Yes.
Is it yours same as mine?
Yes, it's the same.
Never mind, okay. Let's assume this is more than 0.05. So look at the ANOVA table. What's the p-value in the ANOVA table? Compared to my notes, I think some data correct. Okay. What's the value?
Less than 0.01.
Less than 0.001. So what does it mean?
There is a difference.
At least one pair differ, right? At least one pair differ. What's the next question?
Which pair?
Which pair?
What must you do next? Post-hoc, right?
Post-hoc. Yes.
Post-hoc. So go back to ANOVA for the post-hoc. Let's say it's 2 key.
2 key, right?
Yeah, 2 key. Continue and click OK. Now before that, go to option again. Check this box, mean plots. Means plot. You're going to see visually. Continue and click OK. All right. Look at the plot first. Whom do you think is different? At least one pair differ. Obviously, which pair must be different? This is a mean for attendant.
Plus is different.
This is a mean for the nurse. The highest difference between nurse and attendant, right?
Yes.
Okay, if I say at least one pair differ, definitely attendant must differ from the nurse. How about nurse and doctor?
Yes, they do differ.
Okay, we don't know.
Comparatively, yes.
We look at the multiple comparison. Purpose, we want to know who's different. How many asterisk signs are here? How many asterisk signs are here? Yeah?
4.
4 asterisk signs. It means how many pairs are different? 4 asterisk signs, therefore how many pairs are different?
2.
Huh?
2.
2 pairs are different. So look inside the boxes where the 2 asterisk signs are. That's the 2 asterisk signs, right?
Yes.
What does it compare?
Nurse attendant and nurse and
Nurse, attendant, nurse, doctor. It means the nurses are different from attendants and different from doctors. How about doctors and attendants?
not much variation.
Doctor, attendant. Doctor, attendant. There's no difference, right?
No.
There's a p-value. There's no difference. So the conclusion we made the other day was that there is a difference between nurse. So we went through this based on post-hoc test. We said nurses are higher compared to doctors and attendants. Right? This was done earlier. But now I'm going to do the same analysis using a different procedure, that is general linear model procedure. Okay, follow the notes. Using GLM univariate procedure. The same analysis which I did in Way Anova, I'm going to do using GLM procedure. Okay, the data, same data. Follow this procedure given in the notes. Follow the one in the yellow box. So analyze general linear models, univariate, which is a dependent variable. Dependent variable. Class, which is a dependent variable.
SPP.
SBP. Factor. Qualitative variables are factors. Qualitative variables. Quantitative variables are covariates. So factor. Job category, is it a factor? Factors are qualitative variables. All right. Hold on with this. Compare with Way Anova. Are these two exactly the same? In Way Anova, what's dependent?
Job.
SPP.
Here, what's the dependent?
SPP.
Here, what's the factor?
Job.
Here, what's the factor?
Job category.
They're exactly the same, right?
Yes.
Then why you do this? Then why we do GLM?
I don't know.
Can you do Way Anova here? Let's say bring gender. Can I put gender inside here? Two factors?
No, there's
No.
only one factor.
Can I do gender here?
Yes.
Can I do marital here?
Yes.
Can I put age here? That's why it's very, very versatile.
Oh.
For the time being, you're going to repeat the analysis we're done with Way Anova and compare the results here. The same way, let's go to yours is what? Does it have EM means? Do you have EM means in your output, in your dialog box? Is it just option only?
Only option. We don't have the EM means.
Right. Then go to option. Go to option. In option, your box will be something like this. When you click option, your box something like this.
Yes, Prof.
Okay. Click job category inside here. Display means for. Check the box below. Compare means. Change this to Banfroni. Again, if you have EM means, click EM means. If you don't have EM means, the one more button option, click the option button, then we'll come to this dialog. So bring the job category into the right-hand box. Check the box below, compare main effects. Actually, it's a post-hoc test. And choose Banfroni. Here is a limited post-hoc test. Continue. Go to plots. Plots. Job category put into horizontal axis and click add. So this gives a plot like what you got just now. That's all. Anybody still lagging behind? Okay. Once you're done, click OK. You're going to compare the results with what you got in Way Anova. On my left-hand side, this is a result from Way Anova. This is a result from GLM. GLM is called test of between subject effects. I'm going to highlight this row. Check these row values with the first row of the ANOVA. Are they exactly the same?
Yes, Prof.
Right? So there are so many values here. Don't bother. Job category, right? Just look at job category. Basically, what this table gives you exactly same like in Way Anova. So what's the p-value?
Less than 0.01.
Therefore, what's the conclusion? Here, p-value was less than 0.05. Conclusion?
At least
At
one
least
pair
one pair
different.
differ. So now, what's the conclusion based on the GLM results? What's the conclusion here? Same, right?
Yes, it's the same.
At least one pair
pair
differ.
different.
So using ANOVA, we did a multiple comparison and found out who's different. And here, look at this table pairwise comparison. Who is different? How many asterisk signs here? How many asterisk signs?
4.
4 divided by 2.
It's 2 pairs.
2 pairs are different. Which pair?
Nurse, attendant, nurse, and doctor.
Is it exactly same in the one way ANOVA?
Yes.
Right. Look at the chart. Is it exactly same like just now? Nurse was very much higher compared to attendant and doctor. So now, are you convinced what we could do in ANOVA is exactly same as what you got from GLM?
Yes.
Yes. But here we have lot of values to compare. But here earlier, between groups. What's a group? Group is job category. Compare the between groups and these values here. Are they exactly the same? Are these two values exactly the same? Class?
Yes.
Right.
Next, Prof.
Exactly the same. And based on the post-hoc test, we get the same results. And the plots also very identical. So what we could do under GLM, under ANOVA, is the data. So what we could do under ANOVA, we have done exactly same under univariate, isn't it?
Yes.
Are you convinced?
Yes.
Right.
Yes.
If we can do this, why must you do this? If we can do it one way ANOVA, then why do we need this univariate?
Univariate we can do for more than one factor.
Right, more than one factor. So this is called diploma level statistics. After this, lifelong, you won't see this. From here onwards, yours going to be like this. Disagree, Rajan? Disagree, Rajan? Yes, left?
Yes, Doctor.
This one I asked the other day, right? What if the variables are quantitative, right? Qualitative, right?
Yes, yes.
All right. So let's continue. So you're convinced that instead of one way ANOVA,
Yes, yes.
we can do GLM. All right. So one way ANOVA, we're done. This is what I did exactly. Click button here, just follow the arrows. We got the results. These are mean values. Just like one way ANOVA p value, at least one pair differ. Post-hoc test, these two differ. Now, going to continue. Profile plot, you're the same. All right. Two variables. This is BMI. This is job category. Are they both quantitative or both qualitative?
One is
One
quantitative.
quali, one
BMI is quantity. Job category is
quali.
quality. Now, why all very big difference? Right. One quantity and one quality. Definitely, we cannot use one way ANOVA. Definitely, we can't use one way ANOVA. So put it aside. Let's see whether I can do under GLM. General linear models, univariate. BMI. BMI is quantity or quality?
Quantity.
Now listen to this carefully, okay? BMI is quantity. See a rule of that, quantity. goes into covariate. All the qualitative go into factor. Quantitative go into BMI. That's why you must understand what is quantitative and what is qualitative. Are you okay?
Yes, Prof.
All right. Let's click OK. Okay, look at the output. We're going to compare the output we got earlier from the one factor and compare this with this one here. All right. This only job category. Let me take out all this, okay? So less messy. Right. Job category. Was it significant earlier? The job category is significant earlier.
Less than
Yes.
Nurses were higher than doctors and attendants, right?
Yes.
Now, in this analysis now, look at job category. Is this significant?
more than 0.05.
Is this significant?
Yes. No.
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 Here, is it
No significant.
Here? Yes.
Yes.
It's at least one pair differ. Here? No.
No.
Are they contradicting?
Yes.
Which is right? Which is correct? Number one or number two? Right? This where multivariate analysis become useful. So we thought job category made a difference. So actually the test is called ANOVA. What does ANOVA stand for? What does ANOVA stand for? ANOVA stand for what? Analysis of
Variances.
variance. Now, what's ANCOVA stand for? Analysis of covariance, right? ANCOVA, C for co. Analysis of covariance. Are you clear? Co refers to a continuous variable. In this case, the continuous variable is BMI, isn't it? Yes or not? The C and COVA, the C refers to covariate. With a dialog box covariate. This covariate, I put BMI, right? Isn't it?
Yes. Yes.
So we thought job category made a difference. But in the analysis, we found job category was not significant. Right? So now the conclusion is there's no difference in mean BP between job category when controlled for BMI. So what does it mean? So we thought job category made a difference. But the people's BMI may differ from one another, right?
Yes.
BMI, right? So what actually made a difference was BMI, not job category. To show this, look at this slide. Okay, I'm going to put a plot. Before this, look at the plot. What is seen in this plot? What do you see in this plot? After show you how to do this plot. The blue dots are attendants. The red dots are doctors. The green dots are nurses. So what can you infer based on this figure?
It is quite scattered, but it shows that BMI for nurses is more, like roughly.
BMI what?
For nurses is towards the higher side. Only
Right.
two.
Generally, BMI, nurses, the BMI is higher, isn't it? Generally, nurses have higher BMI. Right?
Yes.
Nurses higher BMI. The attendants and low BMI. So it's not the occupation, actually, it's a BMI. So what made a difference, right, for high BP is the BMI, not the occupation. So the variable is significant by itself, no more significant, but you bring in other variables, is called a confounder. Confounder. Meaning it confuses the result. Confounder. So we thought job category made a difference. Actually, it's not. So happened the nurses were obese. So actually, the obesity is the one connected to BP, not the occupation. Right? Okay, let's do the analysis. We already done this. We found there's no difference. Now look at the graph. How does the graph differ from earlier? I think compare the two graphs. Compare the two graphs. How do they differ? This is growth, meaning before BMI. This is without BMI. This is after correcting for BMI. Control for BMI. Can you describe the blue line? Can you describe the blue line? Yeah? Can you describe the blue line?
There is a difference between attendants and the nurse and the doctor.
When BMI
BMI.
it's not corrected with BMI, okay?
Yeah.
When not corrected for BMI, BP among nurses was higher compared to attendants and doctors. Interpret the red line. Is the red line flat, more or less?
Yes.
So when controlled for BMI, there's no difference in BP between the three. So most of the research, we have to do this. So one way Anova is not the answer. Right? Sometimes this is called a profile plot. Profile plot or simply mean plot. Okay. So done this, let's see how to obtain. Look at this chart. This crude adjusted means. What's the mean for attendance here?
120,
120. What's the mean for attendance here?
126,
What's the mean for the nurse?
138,
What's the mean for the nurse?
130.
How come nurse become lesser, attendance become more? Look at the footnote here. What the footnote says? The footnote says, assuming everybody is 1 to 8, correcting for, assuming everybody, sorry, 28.4. Assuming everybody 28.4, correcting for that, we say there's no difference. Why? Because the mean values, BMI values are different. So you must take a common BMI value. When I correct for this now, when I correct for the BMI of 28, somewhere here, so these people tend to go up, these people tend to come down. So don't have to know the details. You just say, when corrected for BMI, the means are about similar. So the conclusion says, there's no difference in mean SBP when controlled for BMI. So BMI is a culprit, not occupation. So happen, most of the nurses in this study were obese compared to attendants. I know in the beginning, a bit difficult to understand this. That's why you have to practice this again and again. So you know exactly what to and how to interpret the results. Question? Okay, let's see how to get this chart. How to get this chart to visualize what's happening. So go to data. Graph. Legacy dialogues. We've done this before, scatter plots. Scatter dot. We've done this before. Define y-axis SBP,
Yes.
x-axis
BMI.
SBP. Okay. Click OK. Okay, generally what you see from this graph? Generally what you see? Generally, what's the interpretation? Yeah? Sunita, what's your observation? What do you observe?
When the BMI is increasing,
Yeah?
and then the SBP is increasing too.
Right. The higher the BMI, the higher is the BP, right?
Yes.
Yes.
They're moving in this direction. Now, I'm going to change the color for the different occupations. Do again. Graph, legacy dialog, scatter dot, define. Now I'm going to use the box set markers by job category. Set markers by job category. And click OK. So look at the graph now. The red color nurses all here, which is high BMI. The attendants are here, low BMI. The doctors are here, somewhere in the middle. So this can show that it's not the job category, rather BMI made a difference. Question? Okay. Shall I proceed?
Yes, Prof.
Right. Just now, one way, meaning one factor. Now, two way, you have two factors, gender and marital status. Look at the next analysis. Still going to use GLM procedure. BP, factor, gender, and marital. Okay, do this. Hardev, 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 are you there? Okay. We're going to do univariate. Let's reset. So what is the dependent variable?
SBP.
SBP. Other two variables are
Gender and
gender. Where does gender go? Into fixed factor or into covariate? Now, forget about the random factor, okay? Forget about the random factor. Either fixed factor or covariate. Gender, where does it go?
Fixed factor.
Fixed factor. Marital, where does it go?
Fixed factor.
Right. So what do you call this analysis? We call one-way ANOVA.
Yes.
Now what do you call it?
Two-way.
Two-way. All right. Now go to plots. Plots. Bring marital horizontal axis. Gender separate lines. We're going to see a plot. Marital versus gender.
Prof, can we do another way round?
Okay, it's okay. Okay. It's the notes what I did. The notes. Marital versus gender, right? Okay. It can do other way around. I'm going to do both. Marital versus gender. And click add. One more. Gender versus marital and click add. Based on the two graphs you see later, we choose one that is easier to interpret. Continue. Go to EM means or options. EM means options. Bring all four into this box. All three, right? Compare means conformity. We want to know how the gender differ, how the marital status differ. This is marital versus gender. Continue. That's all. We follow this slide exactly. Plots we did. Continue. All right. Okay, let's look at this table first. What makes the difference? First, this table. Why this table is important? To check the numbers, are they comparable? If only one person here wants to marry only one person, might as well drop this. Might as well drop this or combine with a single or married. I don't know which one. There shouldn't be one case here. That's a case, drop this or merge with the other groups. So look at this table now. There are so many values, but we are interested only marital and gender. Look at the last column for marital gender. What's the p-value? What's the p-value?
Less than 0.05.
Both, right? So what does it mean?
Yes.
Your
This.
GP differ by marital status and also gender.
Gender.
Now what's the last one? What is the interaction? What are these telling you? Is it also significant? That's called interaction effect. These two are called main effects. The main effects are significant. This is called the interaction effect. So what is interaction effect? So look at this graph. So which graph is easier to look at? Okay, let's look at this graph. The blue line is for
Female.
female, red line for
Male.
okay. Can you interpret this? Are the lines parallel to each other? Are the lines parallel to each other? If this
Yes.
line, no, if this line goes this way, the blue line goes this way, are they parallel? Meaning the difference is similar. Is stable now. Okay. Okay, I insert a table here, new slide. Okay. Supposing this arm here, instead of going this way, it goes in this manner. Are the two lines parallel to each other?
Yes.
The distance the same throughout.
Yes.
The vertical distance same throughout. That's called the lines are parallel. Right now, are they parallel?
No.
No. Here, no difference, right?
Yes.
Here, there's difference.
Different.
When you say the lines are not parallel to each other. When the lines not parallel to each other, we say there is an interaction. How do you explain this chart? How do you explain this? Explain this SBP. Explain for single. Explain for single. The dots are the mean values. How to obtain from here? Single, male, female. That's these dots.
They are
Married,
changed from each other. The value.
female, male. These two dots. Once married, male, female, these two dots. Can you explain how it works? Is there a difference here?
No.
Is there a difference here?
Yes.
Is there a difference here?
Yes.
How do you say it works now?
So
Among those who are single, there's no difference in mean BP between males and females, right?
yes.
Yes.
Among those who are single, there's no difference in mean BP between males and females. Among those married, what's happening?
Mean SBP.
Huge difference.
Females very much higher than males.
Yes.
Among the ones married, is the same?
Also female
Right, females higher.
higher than
So
male.
we want to say this in one or two sentences. Among those who are single, there's no difference in mean BP between male and female. Whereas, among those who are married and once married, the females' mean BP is higher compared to that of males. You like high BP or low BP? High BP better, low BP better?
Low BP.
Then what must you do? To have low BP, what must you do? Don't get married, right? Is that right? Girirajan, are you married? Mr. Girirajan, are you married?
Yes, Gurudeva.
You want high BP or low
Yes,
BP?
yes, Gurudeva.
You want a high BP or low BP?
High
High
BP.
BP, huh? You prefer high BP or low BP?
Yeah, high BP.
You want higher?
Normal BP.
Normal BP. Are you a male or female?
Normal BP.
Okay, are you male or female? Girirajan, are you male or female?
Male.
Male. Then must follow the red line, right?
Male.
I must follow the red line, right?
Yes.
So what must you do?
Yes.
Get
Become-
married once only.
If you're married means you divorce, right? Once you divorce, you call once married, right? And once you're divorced, you call your once married, isn't it? For male, get divorced, your BP will go down
Yeah.
compared to single. For female, if you're married, it's going to go up. Divorce your husband, become single, at least it'll come down a bit. I mean, that's a theoretical data, okay? If I follow this second chart, how do you interpret this? This is female and male. Just now, single, married, once married. How do you interpret this chart? Which line is flat?
Single.
Among the single. There's no difference in married, female and male. Among those who are single, no difference in male and female. That's what I saw here. No difference. Whereas, among those who are married, who's higher? Red line, married. Who's higher?
Female.
Females higher. Among the ones married, who are higher?
Female.
Females higher. Right? So on one statement, you can say, among those who are single,
The mean
there's
female.
no difference in mean BP between females and males. However, among the married or once married, the mean BP for the females are higher compared to the males. Right? So you can't interpret, then you can't write. That's why this particular value is very important. Which direction are going from here? Right? These are main effects. Significant. This interaction effect. How to interpret this? You get one of the graphs with a 1 or 2. Which one easier for you to interpret? They are the same thing. Depends how you look at it. Are we clear?
Yes, Prof.
All right. Again, just doing once may not be sufficient. You have to do a few times until you get familiarized with it. Okay. The study saw there is an interaction effect. How does it work? We see the graph. This is single, married, and once married, and interpret accordingly. Okay, that's two-way Anova.
Professor,
Yeah.
if the p-value is not significant,
Then you don't have to do it. Supposing this
okay.
p-value, where is it? Okay, supposing this p-value.
Yes.
Okay, now what is it? There is a difference between married, they rather say this way. There is an association between marital status and gender with SBP. The marital gender interaction is also significant. Then go to the graph and explain how. If this p-value is 0.123, then it say there's an association between marital status and gender and SBP. This one, silent. Don't say anything about it. Then you don't have to ask for this graph. This graph, you ask for it only when the interaction is significant. Just now it was significant. So I wanted to know how does it work? Right, whatever value, right? In 0.019, I think. It is significant. So tell me how it works. That's how it works. It's not significant, then the interaction remains silent. Are you okay?
Yes, Prof.
Right. So my objective is there an association? Right? Association between BP and marital status and gender. My objective was not interaction actually. It so happened, interaction was significant. Therefore, I must be able to explain how it works. How it works. Right?
Yes, Prof.
When you go and see a doctor, does the doctor ask you, are you allergic to any drugs? Before prescribing medicine, does he ask you, are you allergic to any drugs?
Yes.
Yeah.
Why does he ask you that? Why?
He will not give you the medication that you're allergic to.
But some people take the medication. Some people take the medication, they're okay. Different people react to the same drug differently. That's a form of interaction. Anne, are you there, Anne?
Yes, Prof, I'm here.
Anne, have you eaten durian?
Yes, I have.
Have you taken Coke, Coca-Cola?
No, no, I haven't. Not with it.
No, have you taken Coca-Cola?
Yes, I have.
Have you taken together?
No,
Why?
because I know that I might have an allergic reaction.
What allergic reaction?
Something to do with breathing.
Breathing.
Yes,
Why? You experienced before?
I heard from others.
You heard. How do you know they're telling the truth? There could be
But
something else, right?
just trying to be cautious.
Cautious. How come durian alone is okay, Coke alone is okay, but together not okay? That's all called interaction, right? Maybe Coke alone increases your sugar level. Durian alone also increases the sugar level. When taken together, your sugar level is going to spike. Theoretically, that's what we can explain. How you work, still we don't know. Right? Interaction, how it works. What's the best way to take iron pill? Iron pill? Ferritin? Is it better to take with orange juice? Oh, you're not a bio student. Okay. Never mind. So that's how the interaction is all about. Questions? You've done one way ANOVA. You've done two way ANOVA. You've done ANCOVA. Next, we go into multifactorial ANOVA. In real sense, this is what we will have. Whether manufacturing, whether in the medical, most of the time we have this. In agriculture, right? What combination will give the best results? That's what agriculture people are doing. Which combination will make my product more durable? Manufacturing, they do it. Which comorbid condition, health conditions, make the, let's say, length of stay in hospital? The medical officers do it. So that's what we're going to do now. Right. So more than two variables, and both all are qualitative. Give you an example. What do you want to know? What do you want to know? Dependent variable?
The factors that us.
Not dependent variable.
SBP.
SBP. These factors are
Marital.
marital, gender, category, and obesity. Right. We're going to do this exactly what is shown on the slide. Our objective is to find out which one makes a difference. As I call it, factors associated with BP. Which one or which ones make a difference? Are you ready?
Yes, Prof.
Right. Analyze, follow the steps quickly. Analyze,
General.
PLM, univariate. Let's reset first. What's the dependent variable?
SBP.
SBP. Factors?
Marital.
Okay, just follow this order, okay? Marital,
Gender.
gender,
Job
category. Last one, obesity. Just to follow this order, that's all. Doesn't matter what goes in. Next, this is very, very important. Click the models button. This is a model. Click the model button and follow these steps. Right? We have built terms, keep this, otherwise custom. Right? Custom. Either custom or built terms. Change this to main effects. Make sure you do this, okay? Main effects. Now bring all these factors into the right box. I can do one more time. After entering these variables, click model button. Your build terms, click this. We do have build terms, custom, click that. Change this option to main effects and bring all the variables into the right box. That's all. Continue and click OK. Why this first table is important? Why this table is important? Why this table is important?
To be sure of the population size?
No, to be sure
sample
of
size?
the sample size, not population, not sample
Sorry,
size.
sample size, yeah.
Comparable or not. Right. Next table. Among the variables compared, let me take out this easier to see. Among the variables compared, which variables are significant? Is marital significant?
Gender is not significant.
No, is marital significant?
Yes.
Gender?
Nope.
No. No category?
Yes.
Yes. Hobbies?
Yes.
Yes. So you're going to say that among the tested variables, marital, job cat, and obesity were significant, right?
Yes, Prof.
Right. So next, we want to know how they work. Actually, marital, it makes a difference. Who's higher? Job category. So you must do a post-doc test. Let's continue. When you say job category makes the difference, you must tell who's higher. Go to EM means options. EM means option. Like just now, bring marital, gender note it, because gender is not significant. We want to know how they differ. Compare means confront. Okay. Continue. Click OK. Look at the pairwise comparison. First one for obesity. Who is higher BP? Obese or normal?
Obese.
Obese. Those who are obese, higher mean BP than normal. Next. I'll start from beginning. Okay, start from here. Marital. Marital status. Who's highest? Who's the lowest here?
Married is highest and once married.
Look at this table. How many asterisk signs are there? How many asterisk signs?
Oh,
How many?
oh,
4.
4 divided by 2. How much?
2.
2 are different. So they are inside this cell. What's the conclusion? Married higher compared to single and once married. Right? Married higher than single and once married. Let's go to job category. In job category, how many asterisk signs?
4.
4 divided by 2. 2 groups are different. So which group are different?
Attendant is
Attendant nurse and attendant doctor, right?
yes.
Now, doctor, attendant, there's a difference, right? So now how do you conclude this? Attendance lower compared to nurse and doctor, right?
Yes.
Nurse and doctor, is there a difference? Nurse and doctor, is there a difference? No, right? This nurse, this doctor, there's no asterisk sign. P-value is more than 0.05. No difference between nurses and doctor. The only difference is based on this. Where is it? The next. The next. Attendants are different from doctors and nurses. Last one, obese. You have seen just now. Obese, higher mean compared to normal. Questions? We'll report this now. Presenting the results. Results from general linear models. Okay, let's look at the results. Let's ask for gender as well to complete this table. Let's go back again. Univariate. Yeah, means I bring gender also inside, even though it's not significant. Continue and click OK. What's my objective? What's my objective here?
To find out various factors that affect SVP.
Okay, to determine the factors associated with SBP. That's my objective. To determine factors associated with mean BP. Okay, that's my objective. Right. So all the values we're going to present it in this table X and explain how it worked. Okay. So what test was performed? What test was performed?
General linear model.
Right. In the analysis, I put GLM, okay? In the analysis, the GLM procedure was used. The results are shown in table X. Right. So that's my objective. That's my analysis. And I'm showing the results in this table X. Okay, let's see what goes into table X. Right. Like your first assignment, the same way you put the variables here. What's the difference first assignment and this? First assignment, it was one at a time, gender first, then marital, then job category, then obesity. But here, in multivariate, all at the same time. We call it simultaneously. All right. How to plug in the values? Let's go all over again. Univariate. Let me reset. My objective is to test the factors associated with BP. So I put BP here. What are factors I'm choosing here? Gender, marital, job category, obese. So gender, marital status, job category, and finally obese. So make sure you do this step. Model, custom or build terms, change this to main effects, select all these variables, bring into the right hand box. Continue. Check on EM means or options. Bring all the variables into the right hand box. Compare means and background. Continue. Continue. And click OK. All right, let's go one by one. Gender. Okay, gender. Now it's normal, standard deviation, is standard error. All are corrected for. Earlier in your assignment 1, you have put standard deviation here as value. But here multivariate is called standard error, SE. Otherwise, reporting is quite similar. Female, 127.76, 2 decimals enough, plus minus 2.12. Standard deviation, standard error. Male, that's a value. Right? So you can fill all the mean values first. Next, marital status. So fill up these values here. Next, job category. Fill up the values. Hobbies. Okay, fill up the values. So this column is filled up. Okay, so this column is done. Next, are they significant or not? So go to the test between subject effect table. Okay, this table. Look at variables of interest. Our variables of interest only this. I'm deleting so that easier to see. You can delete this also, okay? Right. What's the p-value for gender? 0.745. All the values are less than 0.001. Are we clear?
Yes, Prof.
All right. Next, Judy said that some are different, some are not. So especially those who are different, you must tell how they differ, right? You must tell how they differ. All right. Okay, as soon as table X, SBP differ by marital, job category, not job, job category, and obesity. Okay, that's what I saw here, not gender. Next step is you must tell how. Based on the post-doc test, check the marital status. Who differ? Marital status, who differ? How many asterisk signs here?
4.
4. That means 2 pairs are different. Who's different? Married.
Single,
Married.
Then single and once married.
married, and once married.
Okay. Post-doc test. Mean SBP among those married higher compared to single and once married. Right. And then job category. Job category. Who's higher? Okay, attendance lower, right?
Attendant.
How do you know? Attendant minus nurse is negative. The attendance will be lower than nurse.
Yes.
Attendant minus doctor is negative. The attendant must be lower than doctor. So among the attendants was lower compared to nurses and doctors. Okay, among the obese, who's higher? The mean BP among the obese was more than those who are normal. Right? Those who are normal. Okay, that's the way we, what's my objective? Right? First, what's my objective? And what analysis we did? In the analysis, I use this. Similar to what our assignment 2 and 3, assignment 2. And then what's the results like? and interpret them. Questions? Okay, that's not the end of the story. Now with qualitative and quantitative variables. Just now, I took only qualitative variables, right? Isn't it?
Yes.
Yes.
Now, I'm going to put quantitative and qualitative variables. So these are quantitative and these are qualitative. Objective the same. See, objective the same, but depends on what variable you are testing, that's all. Objective still the same. Okay, let's do this. Analyze, GLM, univariate. Let me reset. Dependent variable. Dependent variable.
SBP.
SPP.
What are the factors here? Job category,
And marital
marital,
two-factor
BMI,
covariate.
age and BMI are covariant. Next, what must you do?
Model.
Models. Make sure I do this. Build terms, change to main effects, select all, move to the right, continue. Under EM means, I'm going to ask for the means for the groups. Why the age and BMI not here? Why the age and BMI are not here?
Only factor list is added, right?
The list, only these factors coming. That's how you specify is very important. Compare and product. All right. Okay, first look, which variables are significant? I'm deleting all this because easier to compare, okay? But you don't have to do this. Okay, which variables are significant?
All of them.
All variables are significant, right? So reporting again. Right. Let's report job category marital. So job category and marital status. Job category, the p-value is 0.03. Marital status 0.01. So these two are significant. Let's fill up the mean values. Job category. So fill up the job category. Okay. Job category. Okay, job category. So marital status, huh? Okay, marital status. Fill up the value. Single, married, once married. So single, married, once married, plus or minus standard error. Done. And then for marital status, sorry, okay, job category. Job category, fill up this. Same like just now. So this is filled up. So already cleared the first part. First part, you are telling here, there's a difference. Next, which pairs are different? Based on this pairwise comparison, job category, who's different? What's different? How many asterisk signs?
2.
How many pairs are different?
Nurse and a doctor.
Huh?
1 match.
One pair.
One pair. Nurse and
Nurse
doctor.
and doctor. So, nurse more than doctor. Nurses higher than doctors. Next, marital status. Marital status. How many asterisk signs again?
2.
So who's different?
Married and single.
Married and single. Right? So married and single are different. Right. The last two are quantitative variables. So you can't get a means like this. They're not group means. These are quantitative variables. So these are like correlations, sorry, regression. These are regression slopes. So I've shown in that in your notes. To get that, you must click this parameter estimates option. Let's do this. Under options, or year means. In year means, sorry, under options, those under option only. On the left hand side, we have the parameter estimates. The earlier version will be somewhere down here, parameter estimates. So what do you do? Go to options and check parameter estimates. Earlier version, this will be lower somewhere here. Continue and click OK. Look at the parameter estimates table. Parameter estimates table. If I remove the rest, if I remove this, if I remove this, is it exactly like regression? Is it exactly like regression?
Yes.
Right? Let me show you that, okay? So that we can be convinced that what actually it is. Right, let me do a regression. You don't do this, just watch. BP, age, and
Yeah, my.
Yes, I see.
Right. Yeah, look at these two tables. I mean, the values won't be exactly the same. This is a slope, right? In regression, this is a slope, right?
Yes.
Yes.
So here also, that's a slope. That's not going to report. Slope and standard error. Same like slope and standard error. Right. So take these values for age and BMI. Write it below the others. Age. What's the value there? 2.08. Bracket 0.67. So don't use plus minus here. It's not a mean. So that's standard error for the slope. BMI. Right. And the p-values are both significant. So plug in the p-values. Remember, age and BMI are quantitative. So these parameters we obtain from the parameter estimates table, because there's no means for attendance like this. So how does it work? Age, is it significant?
Yes.
BMI, is it significant?
Yes.
What does it mean? The older the person, higher the SBP, right? That's positive, right?
Yes.
Higher the BMI, higher the
SVP.
SBP. So right here, every unit increase in BP, AH, BP expected increase by the 2.02 units. Same as how you interpreted in regression, that value. Ready? Every unit increase in BMI, BP expected increase by that number of units. Okay, that number of units. So this completes ultimately. Mr. Girirajan? Mr. Girirajan? ultimately, this how your table going to look like, right? And that okay, that's how finally your table will look like. Okay. Do the assignment. It's not assignment, exercise. The blood pressure data, these are going to afterwards. But I'm going to do one more for the data set one. Data set one. Test if DBP depends on, we don't have ethnicity, gender, marital, don't have, job category, age we have, weight we have, we don't have this, weight, BMI, weight here, huh? Okay, these variables. DVP depend on gender, marital, job category, age, and weight. With this, you're going to fill up this kind of table, right? Okay. Open Word file. Okay, table Y. Factors associated with DVP. What are the factors? Insert. Variable. That one is gender. Male, female. Next is marital. This is single, married, and not married. Category. Nurses, doctors, and attendants. Last one, age and weight. Mean, plus minus standard deviation, standard error, sorry. Standard error, plus minus standard error, on the p-value. Okay. The heading will be similar to what it is now. The objective was to say mean associated with DBP. Right? So what analysis? The DLM, video, analysis, results, table Y. All right. Table Y. Okay, let's start. Are you ready? Your assignment 4 may require, it's not exactly like this, may require something like this. So go to analyze, general linear models, univariate, reset. So what's the dependent variable?
DPP,
DPP, factors,
Gender,
gender, marital,
uh,
job,
job,
yes,
other
covariate,
covariate age.
age, and weight.
Covariates are continuous variables. And model,
build
Build
term,
terms, manifest,
I bring all inside. Continue. What it
EM,
means,
um,
bring all the variables to the right.
compare,
That means that from here limited.
Bonferroni.
That's okay. At the same time, in the options,
options,
S,
parameter estimates. Because there are some quantitative variable, parameter estimates. You click the option button, the only option button, right? This will be somewhere bottom here, parameter estimates. All right, continue and click OK. Let's see which variables were significant. Which variables are significant?
job category
Job category, age and weight.
and weight.
Gender significant? Is gender significant?
No.
No. How much p-value? Don't say more than 0.05, okay? 0.
0.334.
Marital?
Point
0.132.
32.
132.
132. And job category? 030. And other two, less than 0.001 and less than 0.001. Okay, pretty done. Finish. Now we know which variables or which variable or variables are significant. Next, for quantitative variables, we report the parameter estimates. For qualitative variable, we report there, we call it marginal means. All right. Let's plug in the quantitative variables. Parameter estimates, these last two. Okay, that is 1.459 bracket 0.066 with asterisk sign. Next one, 0.391 bracket 0.034 asterisk sign. So what's asterisk sign means? Regression, coefficients, and SE. Okay, actually they are the slopes. For the rest, so look at the marginal means, estimated marginal means. So complete this, right? For male and female, that's the values. The male value, female value, complete the table. Right, so these two, no difference. So among the tested variables, which variables are different? Significant?
Job category, age and weight.
Tested variables. Only job cat,
Age and weight.
age are significant. Next, tell how it works. Okay. Job category. Give me that. Hello? Okay, sorry. So now, who's different?
Attendant, nurse.
Attendant and nurses are different, right? In BP, I mean DBP among the nurses higher than attendants. And for the two variables, you put here, the older the person, the older the person, older the person, higher DBP, and then the heavier person, the higher. Finish. First, I'm going to tell that's my objective. That's my objective. Right? Next, I'm telling what analysis I used. Next, I'm showing the results. There are so many tables here. Summarize it. Then tell, okay, then interpret all these values and conclusion. So what's the general conclusion? Nurses, older and heavier. Older and heavier respondents have higher DVP. Finish. Okay, that's objective. That's my procedure. This is my results. And finally, that's my conclusion. The conclusion must be in line with your objective. Questions? Okay, open customer data. There's a practice, okay? Open customer data. Okay. Delete these variables. Delete these variables. Household number, newspaper, car type. Delete these variables. So what do you have?
There are 3 or 4. Which ones?
Okay, show the variable view. only these variables will be 8 variables only. Age, gender, marital, residence, income, education, employment category, and car price. So the customer data. Okay, these are variables. Objective. To determine the factor associated with upright. Dependent variable, upright, independent variables, okay, age, gender, marital, residence, income, and employment category. So this exercise, now is 5:20, 5:20, by 6 o'clock, send it to me. Make sure you put the subject exercise on GLM. Subject, you put exercise on GLM. So
Yes, Prof.
what I expect is Word file, something like this. All right.
Excuse me, Prof. Excuse me, Prof.
Yeah.
Can you send us the data in the WhatsApp group, please, again?
Oh, this data I don't
This
have.
data, please.
Customer data. Okay.
Yeah, please, doctor.
Okay, I'll send you now. Customer data.
Thank you. Appreciate it, doctor. Yeah.
All right. I already deleted the variables. I send the one without.
Okay.
Okay.
Thank you. Appreciate it, doctor. Yeah.
That's right.
Mm.
All right. So take it down. That's what I'm supposed to do.
Professor, so now we do this exercise on GLM, right? And send it to
Right.
you at 6 o'clock.
Before 6, yeah.
Yes. So does it mean the class is over, Prof?
Class level. Any question you can ask me.
Yes.
Prof, do we have class on Thursday?
Yeah, what about Thursday? It's a public holiday. Do you want a class or postpone the class?
Want a class?
You want a class?
Yes.
Okay, how many do want the class? Voice out now or never?
Can we still have the class on Thursday?
Okay. Okay, no objections? Okay, class be on Thursday.
Thank you, Prof.
Right.
Thank you, Prof.
Okay. I'm sending how to do the assignment. 3. And also the data, customer data.
Homework, right, Prof?
Homework.
Assignment.
Not homework, classwork.
Okay.
You have finished before you end the class.
Noted. Thank you, Prof.
That's the customer data. And the template. I'm sending this template. Now, it's basically statistics practicing. Nothing extraordinary out of the world. Okay, this exercise on GLM.
Prof.
Prof, my SPSS is not working. I have anymore. I have to reinstall it. Is it okay? I think in this time I can't do this class work.
The Divya's working place. She's joining that.